Hello guys, welcome to the lecture on binomial distribution. Actually, binomial distribution is a discrete probability distribution. So here, first we're going to learn about Bernoulli's theorem. The statement is like this: probability of x in n trials is given by p of x is equal to ncx p power x q power n minus x, where p and q stands for P is the probability of success and Q is the probability of failure, and sum of these two probabilities will be equal to 1, that is P plus Q will be equal to 1. Say for example, in tossing a coin experiment, my wish is to get head as my outcome. So here I can define P and Q. So let P be the probability of getting number of heads and Q be the probability of getting tail. So since a coin is tossed one time, so P of probability of getting head will be 1 by 2 and probability of getting tail will be obviously will get 1 by 2 only. So by adding these two probabilities, so the answer will be 1. So hence the Bernoulli's theorem is satisfied for the tossing a coin experiment. So in the same way it will be satisfied for all the experiments in the probability. So now I am going to discuss about binomial distribution. The formula for binomial distribution is given by P of x is equal to ncx p power x q power n minus x. So since here x is a discrete random variable, the range of x is finite. So it is varies from 0 to n. So now I am going to find the probability function for the binomial distribution. So take all x data and p of x data. So in the p of x equation, I am going to replace x values from 0 to n. So if I replace x is equal to 0 in p of x, my answer will be q power n. If I replace x is equal to 1, I will get nc1 p q power n minus 1. If I replace x is equal to 2, I will get nc2 q power n minus 2 p square, and so on. If I replace finally x is equal to n, my solution will be Pn. So to satisfy the probability density function, I am going to sum entire p of x values. So if I sum p of x values, I got the equation q power n plus nc1 q power n minus 1 p plus nc2 q power n minus 2 p square plus etc plus p power n. So from mathematical induction we have q plus p whole power n. So if I expand q plus p whole power n, I'll get the same equation again. And from the Bernoulli's theorem, already we know the sum of two probabilities will be equal to 1, that is q plus p will be 1. So I got it 1 power n. So since 1 power n will be 1, so I got summation p of x will be equal to 1. So hence p of x is a probability function is satisfied. So now we'll see few now I'm going to discuss about mean and standard deviation of binomial distribution. So since binomial distribution is a discrete probability distribution, I am going to take the mean formula here. Mean is equal to summation x into p of x. So by combining the mean formula and binomial distribution p of x formula, I will get mean is equal to np. So same thing here, n is nothing but number of trials and p is nothing but probability of success. So similarly I can estimate variance also for the binomial distribution from the formula summation x square p of x minus mu square along with p of x of binomial distribution. I will get variance is equal to npq. So here n stands for again number of trials, p is probability of success and q will be probability of failure. So standard deviation already we know it is given by square root of variance. I'll get square root of npq. So now I'm going to discuss about few examples on binomial distribution. The first example, find the binomial distribution when mean is 2 and variance is 4 by 3. So from this data we have to express the function p of x in terms of binomial distribution. So take the formula for binomial distribution first, that is p of x is equal to ncx p power x q power n minus x. So from the given data we have mean is equal to 2 and variance is equal to 4 by 3. And already we know that in the binomial distribution, mean is nothing but NP and variance is nothing but NPQ. So from the given data, I can conclude like NP is equal to 2 and NP is equal to NPQ is equal to 4 by 3. So by combining both the equations, if I replace NP is equal to 2 in NPQ is equal to 4 by 3, I will get 2Q is equal to 4 by 3, Q will be equal to 2 by 3. So once I got Q value, I can easily estimate the value of P from the condition P plus Q is equal to 1. So I will get P is equal to 1 minus Q. Since Q is 2 by 3, I will get P is equal to 1 minus 2 by 3, that is 1 by 3. And we can observe that here, if we add P plus Q, the condition will be satisfied, that is P plus Q will be equal to 1. So after finding P and Q, we can easily estimate the value of N also. So since we are having NP is equal to 2, if I replace P is equal to 1 by 3 in NP is equal to 2, I will get N by 3 is equal to 2, N will be 6 trials. So finally, I'm going to replace all these values N, P and Q in the binomial distribution formula. My equation will be like P of x is equal to 6cx 1 by 3 whole power x 2 by 3 whole power 6 minus x. This is the required solution for the binomial distribution. So I'm taking one more example on binomial distribution, that is when a coin is tossed 4 times, find the probability of getting exactly one head and at most 3 heads. So since here a coin is tossing 4 times, the number of trials will be 4. So I can take n is equal to 4. Find the probability of getting exactly one head. So let P be the probability of success, that is getting head, and Q be the probability of failure, that is not getting head. So if I toss a coin one time, we know that the probability of getting head will be 1 by 2 and probability of getting tail will be 1 by 2. So hence I got it P is equal to 1 by 2 here, Q is equal to 1 by 2 here. So along with that number of trials n is equal to 4 with P and Q values, I am going to replace these two values in the binomial distribution equation. So we have the formula like P of x is equal to NCx P power x Q power n minus x. So if I replace P is equal to 1 by 2, Q is equal to 1 by 2 along with n is equal to 4, my equation will be like this: P of x is equal to 4cx 1 by 2 whole power x 1 by 2 whole power 4 minus x. I will get it. So now actually I want to estimate exactly a probability of getting exactly one head. So it is nothing. So we have to replace x is equal to 1 in the obtained probability distribution equation. So if I replace x is equal to 1 in the P of x equation, I will get 4c1 1 by 2 1 by 2 whole power 3. On simplifying this equation, the solution will be 0.25. Similarly, I want to find at most 3 heads. It is nothing but P of x is less than or equal to 3. So P of x is less than or equal to 3 means the range of the discrete random variable varies from 0 to 3. That is P of 0 plus P of 1 plus P of 2 plus P of 3 will get it. So now with these values, I am going to estimate the P of at most 3 heads. So if I replace x is equal to 0 in P of x, I will get 4c0 1 by 2 whole power 0 1 by 2 whole power 4 plus if I replace x is equal to 1, I will get 4c1 1 by 2 1 by 2 whole power 3. If I replace x is equal to 2, I will get 4c2 1 by 2 whole square 1 by 2 whole square. If I replace x is equal to 3, I will get 4c3 1 by 2 whole power 3 1 by 2. So on summing all this condition, the solution will be 0.9375. So in the next lecture, I am going to discuss few more examples on binomial distribution. Thank you.